Welcome back to a new intuition. In this new intuition, we talk about the difference between the NumPy array and list. So generally, the difference is very bigger because NumPy is way faster than a list, as we know from previous tutorial. But what is the reason behind that NumPy is faster than list? So let's see the reason. First of all, we have the difference table between the NumPy array and the list. So we have so these are several points, and to understand these points, first we need to see the visualization. So the first point is fixed data type and heterogeneous data type. So as you can see that in NumPy array we have a fixed data type, means if we define our NumPy as a integer array, so we can only store the integer data only. But as you know from the Python basic list, we can save the heterogeneous data type data also. For example, in a single list we can save integer, string, boolean, or decimal. So that is the case in list, and in NumPy array we can only save a singular data type data values. So second is can change data type size. So let's take the second data type what is talking about. So in this NumPy array we can change the data type size, and in list we cannot change the data type size. So for example, each element of a NumPy array or each integer element of a NumPy array take default 32 bits or 4 bytes of data. So as you know that these are just a combination of bits. So as you familiar that 1 bytes equal to 8 bit. So we have a 4 block of 8 bits combining up forming a 4 bytes of data. So defaultly NumPy, each element of a NumPy array takes 4 bytes or 32 bits of data. We can change it into 16 bits or 2 bytes of data if we want to change. So, and we can also change it to only a single bytes or 8 bit of data. So we can manually change the data type of data type size of a data in the NumPy array by assigning this int 32, int 16, and int 8. So if we want to reduce the size of our NumPy array, we can change it into int 8. So every element of a NumPy array only take 8 bit of data or 1 bytes of data. But this is not the case for list. For each element of a list, we have 4 metadata. For first is size, second is value, third is reference count, and fourth is object type. And each metadata store different type of information about the element of a list, and each metadata take a specific number of size in the memory. So for example, the size metadata store the size of our element. And size taken by this size metadata is 32 bit or 4 bytes. And the second is value. The metadata, it stored the value of a particular element. So it take 62 bits or 8 bytes. Third is reference counts, which capture the count how many times this particular element is called from this list. So this is also stored in 62 bit data or 8 bytes of data. And last is object type. It stored that what is the object type or value type of this particular element. So in this case it is integer. So this capture the integer data. This captured the type of elements or data type of an particular element. Size of this object type metadata is also int 64. So 64 bits or 8 bytes. As you can see that each element taking this much space. So each element of the list taking if we plus all this size, so 64 bit, 64 bit, 64 bit, and 32 bit, we get 224 bits. So each element of a particular element in list taking 224 bits or 28 bytes of data, and that's a lot of data for a singular integer element only. But as compared to NumPy array, the default value each element can take or an integer can take in a NumPy array is 32 bits or 8 or 4 bytes only. So you can compare 4 bytes with this 28 bytes. List generally taking 4 times more data as compared to this NumPy array. And we can also decrease the size of our element in a array, particular element in an array. So we can change from default int 32 to int 16. So the size taken by the int 16 is 16 bit or 2 bytes. And same with int 8, the size taken by is only 1 bytes or 8 bits. So you can see that there is a lot of difference between the list and NumPy array. Generally NumPy array also reduce the space complexity of our operations or our storage, and list generally increase our space complexity or the or the memory occupy more memory as compared to NumPy array. So this is first advantage of NumPy array over list. It takes less memory as compared to list. And the third is no need to typecasting checking. So you know that in NumPy array we can store only a single type of data type. So so NumPy array know that in this list, in this array only list only number can be saved. So it note so for every element NumPy array has no need to check what is the data type of a particular element. It's know that it is integer. But in the list need to check each element and try to find their data type. So for example, it check for this three element, it is integer. It need to check this hello element, it is string. It need to check this true element, it is boolean. So list need to check all the element data type one by one to have information about that. So it also take a lot of time. So NumPy array eliminate this step by not checking type of a particular element in an array, because it's know that it is static in nature, and their data type cannot change throughout the array. Now last is contiguous memory block. So for example, you know that every variable is stored in a memory in a address block in memory. So when we define a variable in our program, it's stored in our memory in address block. It's assign the variable to an address, and by accessing this address we can access the value of our variable. So for example, we define a 7 element NumPy array with the help of NumPy. So the value stored in the address block is in form of contiguous form. So for example, if the 3 is stored here, 4 is stored here, 5 is stored here. So these values stored in continuous form, one after another. So by accessing the first element of an array, we can access all the element of an array by adding the term. So for example, if we add, so if we access the first address, first element's address, we can access all the element address and do the operations with the help of this only one address only. So you can see that we need to only capture or find the address of a first element of an NumPy array. But as compared to list, data is not stored in a contiguous format in memory. The data is wobbling around in the memory. So for example, the first element of a list is stored here, the second element of the list stored here, third element stored here, the sixth element stored here, and etc. So to access the element of a list, a particular element in a list, we need to search in the memory block or the address block to find the element. We cannot use the same methodology of finding the first element's address, and with the help of this first element address we can access all the element of a list, because the address are wobbling around in the memory block. So we cannot use this functionality to find the address of a first element, and by the address of first element we can access all the element, because there's a gap between them, and maybe some garbage value. So we need to do some searching to find the particular element of a list in the address memory block to access that element. So it also increases the time complexity and also computation power, because it needs little bit more computation power to searching the particular element in a address block. So that is a major drawback in list as compared to NumPy array. That's why we use NumPy array instead of list in our deep learning space. So that's are the reason that beat NumPy array. That are the reason that NumPy array surpass list, and we use NumPy array in our high computational task and representing our data in the form of high dimensionality. So throughout this whole section, if we want to save a list of data or some arrays of data, we use NumPy array and PyTorch only instead of list. So that's why I made this lecture, to giving you proof that why we need to use NumPy array instead of list. So here's the tutorial explaining that advantage of NumPy array over list and why we need to use list. And I hope you get the intuition that why we need to use NumPy array. So from the next lecture, we start basic coding of NumPy array library. So you can start coding alongside with me. There we do step-by-step tutorials of NumPy array, that how we can define the three-dimensional data, two-dimensional data, or single-dimensional data, and do operation with the help of this data. So meet you in the next lecture. Until then, enjoy deep learning.